Okay. So, a few things before going forward. Just yeah, few things I have to see. I'll just verify everything, and if it's everything is right, then I'll go with the presentation. So, yes, if you want to buy a textbook for this particular thing to prepare for GATE, so you, like GATE publication, GATE Academy publication is there, one very good book, GATE Academy publication. So in this, what they have given is like their first thing is small information on each topic they have given. So if you want to know the basic concepts, small formulas, basic concepts, so those things, yes, you can buy this very this particular book. Okay, it has two volumes, and almost everything has been covered in this particular book. I mean, particularly in this particular gate book. Okay, and they have given the clear explanation also. Okay, so it is something like they will take the old question papers, and from those things they have given the information. So this is very like if you want to buy something for power, I mean particularly for gate preparation, I think this is the starting point that you can purchase. Okay, this is a starting book that you can go for. So so let us see some problems from earlier gate questions, so that people will understand what type of questions been asked in the power system, particularly in the uh, power systems area, that too in the transmission area. Okay, so I am not covering everything from right from the 2000, mean 1992 or something like that. I'll just cover from around 2014. So that will be better. From 2014, uh, I will discuss the things. So, so the question is like this: the horizontal placed conductors, the horizontal placed conductors. So, so first thing is horizontally placed conductors. This already I think I have discussed a small thing on this in the last class also. So horizontally spaced. So please see how they are placed. So horizontally placed. Okay. So first thing that you have to observe is horizontally placed. Sometimes they may tell you that at the edges of the at the at the edges at the edges of the triangle. They may say like this. So at the edges of the triangle means, so they were placed like this. So please see, this is the first information that you will get. The horizontally placed conductors means that conductors are placed in this fashion, right? And the frequency is 50 hertz. So this is one more information they have given. Having outside diameter of 1.6 centimeters. Having an outside diameter of, so the diameter is given as the diameter is given as
సార్
6. Yeah,
సార్ సార్
what happened?
సార్ కొంతమందికి అడ్మిట్ అని
Oh,
వస్తుంది.
let me see that why it is so. Okay, it's getting auto admitted. Just a minute. Let me go for the other thing so that just a minute. There is some. Okay, so I have to put it another side so that just a minute. I don't know. There is some glitch at my system at my home. So let me. So just a minute. Just a minute. Yeah, yeah. I think I have seen that. it's not getting automatically changed at my home. I don't know the reason. Just okay. So is there any other options there? Okay. So the question is like this: the horizontally placed conductors. Uh, I think it will get automatically admitted now. Already I have opened the auto admit option. So it is getting locked in. Yes, 50 people are there, right? So it it will do its work in the background. Let me click here. Let me open this here. Okay. So the question is like this: the horizontally placed conductors. Uh, uh, oh, I think I have to put it in full screen, right? Is it so? No. Just a minute. Just a minute. There is some issues. Maximization and minimization issues. So this is the screen. This is the screen of present, right? Again, why it is doing like this? Okay, okay, right. So the question is like this: the horizontally placed conductors means the conductors are placed in a horizontal plane like this. Okay, and sometimes they may also say in some question, some different question, at the edges of the triangle. Okay, at the edges of the triangle means it is in this fashion. It is at the edges of the triangle.
సార్ స్క్రీన్ కనబడడం లేదు సార్, బ్లర్ వస్తుంది.
It is getting blurred. Why
ఎస్
so?
సార్.
Just a minute. Why so? It should not be blurred. Blurred. Okay. Okay. I'll do one thing. Okay, this auto admit will go at my home, no problem. I'll change to my mobile screen so that there won't be any lag and also any other issues. Okay, so let me do that. So let me do that. So let me stop the presentation from this side. So let me go to that particular place. Okay, I'll stop this one. Right. So just 1 minute, I will reconnect through my mobile, so people won't have any problem and issues. So just a minute. Just everything will be in one or 2 minutes. So those things are getting auto admitted. Uh, so where is that? Okay. So right. So I have everything now ready. So let me go for the presentation mode in my mobile. So where is the meet now? Okay, this is me. Right. So okay. So blur and everything. I'll
హలో సార్,
put my yeah. Sir, చెప్పండి సార్.
స్క్రీన్ షేర్ అవ్వట్లేదు సార్.
సార్ స్క్రీన్ షేర్ అవుతుంది, ఇప్పుడు అవుతుంది, ఇప్పుడు అవుతుంది. వస్తుంది అప్పుడు ఈసారి ఓకే కదా సార్? హలో
సార్ ఓకే ఓకే సార్.
ఓకే. So sorry for the delay and everything. So let me start that. Right. So right, where I can write? Yes, from here I can write. Okay. Okay. So, so the question is like this: horizontally placed conductors okay, horizontally placed conductors. So horizontally placed conductors are placed in a horizontal plane like this. Okay. In some other questions, they may also say the conductors are placed at corners or edges of a triangle. Okay, of a triangle. So they may also say like this. So in this case, it is given as this is a different case, and this is what we are dealing with: horizontally placed conductors. Okay, so frequency is given as 50 hertz. Frequency is given as 50 hertz, and the outside diameter. See, outside diameter of the conductor, outside diameter is given as 1.6 centimeters. 1.6 centimeters. Okay, 1.6 centimeters, and the spacing between the centers of the conductor is 6 meters. The spacing between the center of the conductors is so center. So please consider the center. Okay, from center it is 6 meters. This is 6 meters. Okay, so this is the case, and they have given the permittivity of the free space. The permittivity of free space is the permittivity of free space. Free space is given as 8.854 into 10 to the power of minus 12 farad per meter. The capacitance to ground per kilometer for each line is. So they are asking the capacitance to ground per each kilometer of the line is. So this is the question. So horizontally placed conductors. So they are 6 meters apart from the center, and the frequency is 50 hertz. The outside diameter of the conductor, the outside diameter of the conductor, the outside diameter of the conductor is the outside diameter of the conductor is 1.6 centimeters. The permittivity of free space is given as 8.854 into 10 to the power of minus 12 F by M, capacitance to the ground per kilometer of the line. So almost every year, right from 2014, every year you are getting one question similar to this particular type. Okay, one question for this particular type. So it may be on capacitance, or it may be on inductance. Okay, so it may be a capacitance between the conductor and earth. Okay, it may be a single phase, or it may be a three phase, or it may be a uh, double spaced conductors. Okay, double circuit and three phase power system. Okay, double circuits. So a question can come from this particular area. So if you see this particular question properly, I think this is enough. If you do this properly, I think if you can write it properly, at least if you can analyze it properly, that is enough that you can attempt this question in whatever the way they may ask you. Okay, if you properly follow this question, you can write it in the whatever the way they may have asked you. So the first basic twisted thing that they will do is that the conductors are placed in a horizontal plane. So horizontally placed conductors means the conductors are placed in a horizontal line like this. So please keep this in mind that this is what you have to consider. Okay, or they are placed at the corners of a triangle, or they are placed like a something like in a specific point. Okay, if you can get it properly, then this is enough. Okay, and one thing that you have to consider is they have asked you for a three-phase system or a single-phase system. Okay, so in this particular case, they have not mentioned it is a three-phase system. So they have not mentioned a three-phase system here. They were like at any particular place, they have not mentioned that it is a three-phase system. Okay, so that you have to keep it in mind. Okay, so whether it is a three-phase system or a single-phase system. So again, I don't know what happened to my system. So let me change the orientation here. Something is not okay with my mobile. Okay, so horizontally placed conductors. So this is what they are saying. Is it a single phase system or a three phase system? Please keep it in mind. So is this third one is present or not? Please verify. Please read the question properly. So if you read the question properly, then I think it is almost safe to say the question. So in this particular question, they are asking it about single phase system. Okay, I have not mentioned that in the question. That is the reason I have drawn three conductors here. But clearly they have mentioned that this question is for single phase system. Single phase system. Okay, it is for single phase system. So please keep this in mind that which type of system they are asking it for. Okay, so it is a single phase system. So that is the first observation that we have to see. Right. So what is the next observation that we have to see? That the conductors are placed from the center. This is the distance. They are saying it as distance. Distance is 6 meters. Okay, 6 meters, that is given in meters. This is the second observation that you have to see. Next one is diameter. They have given the diameter. You have to convert it into radius. So radius is 1.6 centimeters by 2, and you have to convert that into 1.6 is something like 0.8 centimeters. Okay, and the third observation that you have to see is in what form they are asking. Okay, so they are asking you to calculate the capacitance per kilometer. Okay, please keep this in mind. They are asking you to find out it for per kilometer. If they are not asking you to find it out for centimeters, they are not asking you for meters. They are asking you for kilometers. So these are the three observations that you have to do. You have to do properly if this question is asked. Okay, so definitely from 2014 onwards, they are asking one question from this particular area. So the first thing that you have to see is whether it is asked for single phase system or not. So that you have to see. So how they are placed horizontally or in a triangle shape, that you have to observe. That is the first observation that you have to make. The second observation is they have given the diameter. So convert that into the radius and keep it in one form. Okay. The next thing that you have to see is what they are asking it for per kilometer they are asking. So if you make all these observations in the earlier stage at the first stage, then I think you can easily do this question even if it is asked in this particular 2021 also. Okay, the basic observations that you have to make. Okay, so done. Yes, so basic observations are made in this particular question. So what next? What we have to do is the formula. Okay, so capacitance formula, something like if you want to do it for phase to phase, two phases are there. Then pi epsilon not epsilon r by, so earlier one it is epsilon, So epsilon is epsilon naught into epsilon r ln d by r. This is between two phases. Okay, if you have two phases, two phase conductors like this, it will be this particular formula. Okay, only this confusion is there for single phase. For three phase, there is only one formula. Okay, so what we have here is this is the formula. So this is for phase between two phases. So let me do that. This is phase as well as this is also phase. If you want between neutral, then it is if you consider the neutral conductor like this, neutral conductor like this. So it will be 2. So you have to multiply that 2 pi epsilon naught epsilon r by ln d by r. So d is the distance, r is the radius. Please keep those in mind. D is the distance and r is the r is your value, right? So they are asking it for neutral, right? So 2 pi epsilon naught into epsilon r. So epsilon r is consider it as 1. Epsilon naught they have given it is 8 point. What is that value? 8 point. Let me go for the top. So they have given that it is 8.854 into 10 to the power of minus 12. 8.854. 8.854. Sorry for that. 8.854 into 10 to the power of minus 12. Okay. So after substituting that between phase and a neutral, this is what you have to consider: 2 pi epsilon naught epsilon r by ln d by r, ln d by r. So 2 pi into 8 to the into 854 into 10 to the power of minus 12. Here I can't write it, so let me rewrite it again. So let me reduce this diameter so that I can write it little. 2 pi epsilon naught is 8.854 into 10 to the power of minus 12 into 1 by ln. So here it is 6 meters and the bottom one is centimeters. So convert that into meters. Okay. So this gives you capacitance in farad per meter. Okay. Please see, all your formulas are in the form of farad per meter only. Okay. So if you convert that into kilometers, so something like 10 to the power of minus 9, you will get 8.404 farad per kilometer. Okay. So all your formulas are in the form of farads per meter only. So this is what you will have. Okay. So this is for between phase and neutral. Okay. So question is clearly asked, what is the capacitance between phase and neutral? Okay. So the same question, if it is asked something like between earth. Okay. If it is asked between earth. So what will be your formula is pi epsilon naught epsilon r by. Okay. You can take epsilon r as 1. So let me remove that. So let me take it like this, pi ln 2h by r. So if you have capacitance, this is will be 2h. So what is that? So this is a conductor, your earth. Another conductor will be there like this. So another conductor is there like this. I can't write it here. Okay. So that is second phase. Okay. So let me. So you have another conductor like this. So this side is h and this side is h. Okay. So that is 2h. Okay. If you have a single conductor, single phase, single conductor and earth, if they are asking to find the capacitance between the conductor and the earth, so this is your formula. So if you read this, I think that for capacitance, inductance, you have 3 formulas, very easy formulas. For capacitance, you have 3 formulas, and for earth and capacitance, you have 3 more formulas. But here, almost this first single phase, I mean, basic things will be like something like ln d by r. This may not change. So d is distance, r is radius. So these things, if you remember properly, I think mostly it is sufficient. Only for inductance, it will be r dash. For L, it is r dash. Okay. So it is 2 pi into 10 to the power of minus 7 ln d by r if you get something like this for inductance, so for capacitance you will get pi epsilon naught by uh, ln d by r. Okay, it is as similar. If you compare like this, if you compare like this and remember them, then it is very easy for you to write, solve this particular problem easily. Okay, so these are the observations. So one question I have taken, these are the all observations that you can make out of this particular one question. Okay, if you do this, I think you can do any question that is coming out of from this particular chapter. Okay, so proper observation that you have to make. So we will see one more problem from this particular chapter, so that it will be like something like uh, a practice problem. So radius of each the conductors are arranged as shown below. Okay, so that right. Uh, Let me take one difficult problem so that, so from 2015 there is there, 15, 16, 17 is also there. So let me take one difficult one so that you can get more information out of that. So what is that? So, so which one I have to take? Which is the difficult question that I can take? Three-phase. Okay. So, so from 2017, I will take one question. See, basically, I am taking one question and I am telling you what are the things that you have to observe if similar question is been asked. Okay. So this is very advantageous if you follow this properly. So that when you get a question from this particular chapter, what are the observations out of that question? What are the observations that you can make? So if you see the problem by within 30 seconds, you can if you can make all these observations, then directly you get the formula, apply it, you will get the answer. That's it. Okay, not more than 30 seconds to get the information, and to solve that maybe you may get around 1 minute. Okay, for putting that into calculator and getting the answer, maybe you may take it 1 minute. So 1.5 minutes you can definitely you can conclude, complete this particular question. So let me take the question from 2017, which is 2017. So consider an overhead transmission line. So overhead transmission line with three phases. So now in this case, they said this three phase. So 50 heads system. So 50 head system. Conductors located at the vertices of an equilateral triangle. So, so this is the terminology they are using. So conductors located at the vertices of an equilateral triangle, equilateral triangle of length DAB is equal to DBC is equal to DCA is equal to 1 meter. As shown in the figure below, they have given the figure also. Okay, as shown in the figure. Okay, figure they have given. So I will draw that figure at the end. The resistances of the conductors are neglected. So they are considering the resistances of the conductor are neglected. So mostly it is in this particular chapter, they are mostly neglected only. Okay, but in the second chapter, where you go for the short, medium, long transmission line, definitely resistance will be considered. So the resistance of the conductors are neglected. The geometric mean radius. So geometric mean radius is given as 0.01 meters. Neglect the effect of the ground. Neglecting the effect of ground. The magnitude of positive sequence reactance is the magnitude of positive sequence reactance is kilometers. Round it off to 3 decimals is, they are asking this particular question. So it is a fill in the blank, not a multiple choice question. Okay, it is a fill in the blank, not a multiple choice question. So I think around 2016, 2015 itself, they have changed the pattern of particularly gate. So from 15 onwards, they are asking the fill in the blanks also. Okay, so around 15, they are asking the fill in the blanks also. So you have to solve this problem. They don't have any ABCD actions here. So if you solve it, then only you will get the answer. But it is easy if you read the question properly. If you read the question properly, most of the people don't do this. They don't read the question. They will only see that, okay, this is very big question, so let us skip this question. But it is not like that. So for power systems, if you read that, it's very easy. Just just an implementation of a formula. Just you put a formula, you'll get the answer. That's it. Okay. So analyzing part only comes at the end. Okay. If anything else is required, something is added to that. So that comes at the end only. Right. So let us see this question once again. So 2017 question. So overhead transmission line, 3-phase. They have given it is 3-phase system, 50 heads. Conductors are located at the vertices of an equilateral triangle. So they have given the figure like this, an equilateral triangle. They have given the figure also. So, so it is like this. So C, they have mentioned the figure also. So I am taking that figure here. So DCA, this is distance of DCA, distance of AB, distance of BC. Okay, they have given this figure. So there no worries in there. Okay, so 1 meter, the distance also 1 meter apart. That is what they have considered. So next thing is resistance of the conductors are neglected. This is mostly if it is from this particular chapter, they will neglect this resistances. So next is GMR. So geometric mean radius they are given as 0.01. Neglecting the effect of ground, the positive sequence reactance is. So they are asking it in the form of reactance. They are not asking in the form of inductance. So it is not the end. Inductance is not the end. If you calculate the inductance, it is not the end. So they are asking for reactance. They are asking for reactance, not the inductance. Okay, but the question is from first chapter, that is calculation of inductance capacitance only. So that we have to complete this problem with the help of the formula that we have, right? So again I'll draw that particular figure. So we have a equilateral triangle like this. So like this. So from an equilateral triangle, we all know that the sides are always equal. So the length of sides are always equal. So this is the figure they have given already. So this is DAB, DCA, DAB, DBC. So somebody can anyone tell me the formula for this one? Can anyone tell me the sorry? Can anyone tell me the formula for this one? Please switch on your mic so that I will know if people are there or not, whether they are asking you are listening or not. I don't know. So give me an answer. So switch on your mic and give me an answer. So what will be the formula for this particular problem? It's very simple question. Very simple question. They are asked it for 2 marks. So just an application of formula that you learned in the last class. You have 6 formulas, inductance and capacitance. If you include the earth, capacitance will have 3 more formulas. So almost they may earth effect maybe up to 3 phase they may ask. So just if you know the formula, implement that, you'll get the answer. That's it. Okay. So give me the answer. Tell me the formula that I have to use in this case. Okay. So let me show the question again. So a 3-phase system, a 3-phase equilateral system is given. So 3-phase system is given. The conductors are located at the at the vertices of equilateral triangle, and the distances are given as DABC, DBC, DCA is equal to 1 meter. The resistance of the conductors are neglected. The GMR is geometric mean radius is given as 0.01 meters. Neglecting the effect of ground, positive sequence reactance is in the form of resistance, ohm per kilometer. They are asking ohm per kilometer. So this is it. So yes, so I need an answer from your side. So what is the formula that I have to use it in this case? So what is the formula for inductance L? So for reactance, if you want to find, you have to find the inductance first. So that is something like XL is equal to 2 pi FL. Okay. So if you can find the L, so substitute that L, you will get the XL value. So that is what they are asking. Okay. So now tell me, what is the formula that I have to use in this case? So somebody please switch on your mic and tell me the answer. If somebody is talking, I don't know. So I have to go back.
2 into 10 power of minus 7.
2 into 10 to the power of minus 7.
ln by ds.
D? What is that? Tell me. D?
2 into 10 power of minus 7 ln by ds.
D by ds. What is the D by ds?
Three phase conductors.
So again, I'll tell you the formula is very simple. The whatever the thing is that you have to take a mutual distance. Okay, the mutual distance or GMD. You have to be on top. So simply to say this is GMD and it is GMR. Okay, this is the formula. But here the GMD will be 3 cube root ABC. As all the three are same, so that is equivalent to D. So which is equivalent to 1 here. So it will be 1. Okay. So GMR they have given it as 0.01 meters. 0.01 meters. This is already 1 meter here. Okay. So we got those things. L is equal to 2 into 10 to the power of minus 7. So ln 1 by 0.01. This is Henry per meter. Okay. So you will get, if you solve this, you will get around 9.21 into 10 to the power of minus 7 Henry per meter. Henry per meter. So if you convert that into 10 to the power of minus 7 Henry per kilometer. Sorry, 3. Okay. So if you want to find XL is 2 pi FL. So substitute that L. So finally you will get 0.289 ohm per kilometer. So please keep it in mind. Your inductance is always in the form of Henry per meter. So you have to convert that into kilometer because clearly it is asked to find the resistance per kilometer. Okay, reactance per kilometer. Okay, so that is what you have to do. So this is the final answer that you will get from this particular question. Okay. So please, again, I am telling the observations that you have to make. The question is very, very easy. Only thing is the observations that you have to make patiently. If it takes only 30 seconds, mostly it takes 30 seconds. Just read the question, write it at one place. Everything is clear. Okay. So just an implementation of a simple formula, that is L is equal to 2 into 10 to the power of minus 7 ln GMD by GMR. Okay. As simple as that. Okay. Done. So that is your answer in this case. So I think this concludes this particular chapter. So I think 2 more questions are there. So I try to share this material with you. Actually tried last class itself, but it not happened. But definitely I will share it in this particular one. Okay. So this is the related to your power system to transmission system, particularly for calculation of inductance and capacitance. So quickly I will summarize everything from this particular area. Okay. So what we have here is we have a single phase system, 3-phase system, and double circuit system. Okay, double circuit system. Okay, right. So for single phase L, you will have one formula which is given in the form of Henry per meter. Capacitance. Okay, all 3 things will have capacitance. it is farad per meter. And also they may ask you between capacitance to earth, it is also farad per meter. Capacitance to earth. Okay. So each you have three formulas for single phase, three phase, and double circuit. You have three formulas for here and three formulas here. So for particularly single phase horizontal, it is okay. Particularly you have to see the three phase system. So three phase system, you have two configurations. So it can be placed in a horizontal system or it can be placed like a triangle system. Okay. So this is the simple observation that you have to see. Next, for inductance, what you have is for inductance, that is 2 into 10 to the power of minus 7. So ln GMD by GMR. Okay. So this is 0.707 into R GMR will be. Okay. So for capacitance, so capacitance is pi epsilon naught by ln D by R. Okay, this is just R, but in the inductance it is R dash. Okay, don't get confused here. So this is the simple formula that you have to remember. D is distance, R is radius. Okay, so these are the simple observations that you can get out of this particular chapter. If you have everything from this, so you have, I mean, you can solve everything. Okay, so maybe I have given a, I mean, 70. Can anyone tell me this value properly? 7086. I remember it as 86. Simply it is, you can, okay, 7788. Yeah, sorry for that. Uh, I took it as something else. So it is 0.7788. Sorry for that. Okay. GMR is R dash actually. Remember that. Okay, 7788. The remaining things are same. Right. So, so this is the questions that you can expect, and that is the summary of all the things that you have here. And try to solve some more questions on that. You will get everything. And for particularly coming to the second one, this is about the short, medium, and long transmission lines. Sorry, I'll write it here. Short, medium, and long transmission lines. Let me have a sip of water. I'll continue it. Okay. So before that, you just get ready with the answers, the distances, how many kilometers will be called as short, medium, and long. You can post them into the chat box. Okay. At what kilometers it is short, and what kilometers it is medium, and what kilometers it is long. Okay. Before I'll take a short water break in just 1 minute. So you get ready with these answers. Okay, you get ready with these answers and try to post them into the chat box. Please post them into the chat box. Please post the answers into chat box. Let me see the chat box. So quickly, please post your answers into the chat box. I'll see the answers. So question is at what kilometers you will call it as long transmission line, at what kilometers you will call it as medium transmission line, and at what kilometers you will call it as long transmission line. That is the question. So try to answer that. Post your answers into the chat box. At what kilometers you will call it as medium transmission line, short transmission line, and long transmission line. So Arun Kumar, 80 kilometers is short transmission line. So let me see everything. Okay, you are posting the questions into the chat box. Don't worry, you can switch on your mic and you can tell the answer. Maybe I may not be seeing the chat box. That is the reason. Okay, so 7788. Yes, right.
Sir, less than
So
80
80 kilometers. Short,
kilometers is short
less than
transmission
80 kilometers is short transmission line. Okay,
and medium is 80 to what 240 kilometers.
80 to 240 is
Medium
medium transmission line. Okay, long
and long
transmission line
transmission is above 240.
about 240. Okay, any other answers? Any other answers from the other people? Any other answers from other particularly other people? Like any other answer apart from that? Medium transmission is 160 kilometers. Above 160 kilometers is okay. So okay, so I can take this particular answer. Somewhere around 80 kilometers. Short transmission line is 80, 80, 80, 300, 160 long. Okay, okay. So it is debatable, but mostly I'll take this one. Particularly, one person has posted something like so short transmission line. I will take it as 80 kilometers. Okay, short is around 80 kilometers, 80 km, and medium is around 80 to 160. I'll take it as 80 to 160 kilometers, and long transmission line I'll take 160 above. Okay, so everything is in kilometers. But see that actually from 140 kilometers itself, the long transmission line principle starts. Okay, actually from 140 kilometers itself, 140 kilometers itself, the long transmission line parameters will start. What is this long transmission line? I mean, uh, what is the specialty of that long transmission? Basically, what happens is due to the effect of due to the effect of uh, capacitance and inductance due to the effect of capacitance and inductance of transmission line. This is very important observation. So due to the effect of capacitance and inductance of the transmission line, the receiving end receiving end receiving end voltage, so taken as receiving end voltage taken as VR, is greater than sending end voltage Vs. Can anyone tell me the what is this effect is known as?
Ferrante effect, sir.
Sir, Ferrante
Somebody,
effect, sir.
uh, yeah, it is known as Ferrante effect. Sai Venkat has told me that it is Ferrante effect. Okay, so it is like it is very easy to remember. It is just VR is greater than Vs. Okay, but sometimes it can be asked as a bit something like uh, related to sometimes it is related to your power system, particularly in this particular area. So it is Ferrante effect. But this occurs only at only at uh, lines above 140 kilometers and at no load or lightly loaded conditions. Lightly loaded conditions. Okay, please keep this in mind. No load or lightly loaded conditions only this current effect will occur. So receiving end voltage VR is greater than sending end voltage, called as Ferranti effect, and the lines 140 kilometers above 140 kilometers with no load or lightly loaded conditions, this particular effect will happen. Okay. So practically, this is the thing that you have to know about in this particular chapter. So 80, 82, 160, 162 above is this. Okay. So next thing that you have to see is we have short transmission line, short, medium, and long transmission line. So short transmission line, you don't have any capacitance effect. This is one more observation that uh, no effect. No effect or not considered negligible simply. So line is simply R plus JXL. Okay, R plus JXL. From medium and long transmission line, you can have two configurations, that is pi and T representation. Pi and T representation. What is this pi and T representation? So pi representation is you have to divide your total capacitance of the transmission system into two halves, something like this, and be placed at the either end of the sending end and receiving end. Okay, it's placed at either end of the sending end and receiving end. Okay, I think okay, I lost the okay, let me close this. Right. Okay, the total capacitance of the transmission system is divided into two halves. One is placed at the sending end. This is Vs sending end at this particular point, and the other half is placed at the receiving end, that is Vr. Okay, please keep it in mind that the pi representation is the total capacitance is divided into two halves. One is placed at the sending end and one is placed at the receiving end, and the line impedance is given as Z is equal to R plus JXL. The line impedance is given as R plus JXL. Okay. So this is about the pi representation. About the T representation, so all the capacitance of the transmission line is lumped at the center, simply given as C. All the capacitance of the transmission system, all the capacitance of the transmission system will be lumped at center, and the line impedance is divided into two halves and placed at the either end of that capacitance. Either end of that capacitance. So this is Vs and this is, so something has closed. Please, I am still connected. So let me come back. Right, 1 minute. I lost. I mean, something has been forced to shut down. So is it there still? No. What happened to relay? Somewhere I'm writing there. It was lost. Just a minute. Just a minute. So where is that sentence? Okay. So phone is getting overheated. Let me remove this thing. Okay. So that is okay. Okay. So complete capacitance is lumped at one end, and the at the center, and the impedance is make half and placed at the either end of the capacitance. So Z by 2, Z by 2. So this is Vr and this is Vs. Okay. So this is what we have for pi and T representation. Okay. So for short transmission line, very easy, simple. So this is Z, this is Vs, and this is Vr, like this. Okay, this is Is and this is Ir. So Is is equal to Ir in short transmission line, and Vs is equal to Z, the current through that into the impedance, this Is plus what is that? Yeah. Okay. So we have an equations like Vs is equal to AVR, is it AVR? AVR plus B IS or IR, and Is is equal to B, is it C VR plus D IR. This is IR actually. Okay, here Is is equal to IR. That is the reason I wrote it like that. Okay, so Vs Is are related like this. So Vs Is is equal to AB CD into VR IR. So if you compare these equations, A is equal to Z in this case. A is equal to Z, or is it okay? Is. So IR is equal to Is or IR. This is, I can write it as Z is plus Z into IR. So sorry for that. So IR plus VR. Okay. So comparing with these two, comparing these two. So what I will get is A is 1, B is Z, C is 0, D is 1 into VR IR. So simply AD minus BC is equal to AD minus BC should be equal to 1. So in this case AD is 1, BC is 0, which is equal to 1. Okay. So for short transmission line, this is what you have to remember. Vs Is is equal to Iz 0 1 VR IR. Very important and easy to remember. Okay. The only thing is you have to remember these equations. Is is equal to IR and Vs is equal to Z plus Is plus Z into Is plus VR. Okay. So this is what you have to see here. And for medium transmission line, so AB CD, this will be 1 plus YZ by 2, Z, Y into 1 plus YZ by 4 into 1 plus YZ by 2. Okay, this is for medium transmission. ABCD will be of this form. For pi, this is pi representation. For T representation, ABCD will be 1 plus YZ by 2. This is same. Z into 1 plus ZY by 4, Y, and 1 plus ZY by 2. I am not discussing about how I got these equations. I think it is already covered in the regular classes. So just we require formulas. So I am reviewing the formulas only. So just whatever the coefficient that is there here, it goes to the Z here. Okay, if you can remember this, for pi representation, if you can remember this, so just this term, whatever that multiplication term that is there, just transfer it to Z here. Okay, so that is enough. You know, you will have two formulas here directly, so where you can use them easily. Okay, so this is for medium transmission line. Okay, for long transmission line, can anyone tell me the long transmission line? Can anyone tell me the long transmission line? In what form they will be? At least ABCD terms. In what forms they will be? At least adana cheppandi. Not like you tell me the formula or at least like that. Something you have to remember. What is that? In what formula you will have them?
Exponential.
What okay, exponential is okay. One answer. Any other form? Simple to remember, easy to get at the answer, easy to get the answer. Anyone else, please respond. Can anyone tell me in which form they will be? Sorry for that. In what form they will be? Anyone? They will be hyperbolic tangent functions. Simple. I'm able to write here. So let me take this. Hyperbolic tangent functions. And they will be in the form of gamma L. What is this gamma L? Can anyone tell me? Okay. Hyperbolic function of gamma L. Can anyone tell me what is gamma L? You have to give the answers. At least what is gamma L? You have to know what is gamma L. What is in this case? What is L here? L is the length of the transmission line. What is gamma? Give me some answers so that it will be an interactive session rather than something like one-way traffic. If you give answers, it will be an interactive session. What is gamma here? Long transmission line. Nobody remembers it? Nobody remembers that? Okay. So, Nagaraj sir, are you there? Nagaraj sir? Hello? Sir, Nagaraj sir? So, yeah, it is in the form of hyperbolic tangent function. That is, I mean, hyperbolic functions, not tangent functions. Tangent is tan. That one will come. So, sorry for that. Actually, it is in hyperbolic functions, simple hyperbolic functions. Propagation constant. Okay. Wavelength. Okay. What else? What else that you can have here? I can take it as something like wavelength or propagation constant. Wavelength, propagation constant, or wavelength it is. Okay. So, sir, Nagaraj sir is there here? No, I think it's not present. So, let us take a break for 5 minutes. 5 minutes is enough. Okay, because my phone is getting heated up. So, I'll take 5 minutes break so that it gets cooled down. I'll stop presenting for 5 minutes. So again, I will start presenting after 5 minutes. Okay, exactly after 5 minutes, I'll start presenting. Even uh, uh, my charging is also down. Okay, so 20%. It is almost 20%. So I'm recharging my mobile. At least 5 minutes. I'm giving a break. Okay, so I'll stop presenting now. So after exactly 12:18, I'll start presenting. Okay, so please come back after 5 minutes. Okay, so I'm stop presenting now. My phone is getting heated up. So let me recharge my mobile again. So please take a 5 minutes break and come back. At exactly 12:18, I will start presenting again. Okay. In interim, you can ask some questions so that I can answer those. Okay. So in interim, you can ask some questions. In interim, you can ask some questions. Have questions, please try to ask them now. So it's 5 minutes you can utilize. It's not like complete break. If you want to utilize, you can utilize this particular 5 minutes also. It is very crucial. So, so if you have any doubts, try to ask them. So I have not discussed the phasor diagrams and those things. But basically, if you want those things also, we can discuss, but it takes a lot of time. That is the reason I have not discussed those things. Any questions particularly, you can raise them. My phone is like, it's completely too hot. So let me close everything in the background. This is gone. This I'll close, this I'll close. This. So many apps are opened in the background. Okay, closed everything, right? So fault effect on three phase. Yeah, I will discuss those things, Sai Venkat. But I am going in a sequence, so that is the reason I am not touching them now. Uh, Fault effect on three phase, definitely I will discuss those things at the end. Okay. How to get voltage levels in the transmission line set. Set voltage levels. Voltage levels in transmission line are already fixed. Something like your generation voltage is around 21 kV. So from 21 kV, now they are at present what they are doing is they are transferring the, converting that 21 kV into 400 kV, 400 kV. 400 kV then will be transmitted through transmission lines at 400 kV. Then again they are stepping them down to 220 kV, 132 kV, 66 kV, 33 kV, 11 kV, and finally our uh, three phase system 400, 440 volts. Okay, that is the voltage that we will get at our home is around 240 volts, 230 to 240 volts. The extra 10 volts is for something like when you connect the load, the whatever the drop voltage drop is there. So to accommodate that, we will provide an extra voltage at the distribution side. Uh, Fault effects, yes. Anything else, Rajesh? I think I have answered that. So 21 kV generation, 400 kV transmission, step down to 220, 132 kV, 220 kV, 132 kV, 66 kV, 33 kV, 11 kV. Okay. Okay. So 21 kV, please remember that 21 kV. 33 kV is also possible for generation, but in India it is not being used. Only 21 kV they are using. Okay, 21 kV to 400 kV. Okay, 400 kV to, there is possibility that 765 is also there, but remember it is only 400 kV. Okay, 400 kV. So yes, the time is now back to 418. So let me start presenting. Okay, right. So we have discussed about the small things that is related to power system, transmission system, particularly short, medium, long transmission system. So let me go back and discuss about the other things about the long transmission. Okay, long transmission line ABCD parameters I am giving them. ABCD parameters are given in the form of hyperbolic functions or exponential. Somebody has said that it is given in the exponential functions. Yes, both ways hyperbolic functions. If you mention them in the form of hyperbolic function, yes, definitely you can mention also them into the form of uh, the exponential terms. Okay, so here it will be cos h gamma l. Okay, and zc. So I think my audio is not bad. I hope so. So sin h gamma l, cutting there. So I have to erase and I have to write it again. So let me write it here like this. So this is hyperbolic form or exponential form. In two forms we can represent that. So this ABCD long transmission line ABCD will be cos h gamma l zc sin h gamma l 1 by zc sin h gamma l cos h gamma l. Okay, cos h gamma l. So for cos h gamma l, if you want to know what is cos h gamma l, that is e gamma x, I mean exponential gamma x plus exponential minus gamma x by 2, and this is L, gamma L, and sin h gamma L will be E gamma L minus e power minus gamma L by 2, exponential minus gamma L by 2. Okay, these are the things, right? So long transmission line, particularly the things that you have to know here is one particular concept is surge impedance loading. Okay, one extra concept that you have to know is surge impedance loading. Surge impedance loading. What is the surge impedance loading? So surge impedance loading, it is very essential for long transmission system. So particularly when you want to predict the maximum loading capacity of the transmission line, when you want to simply calculate the maximum loading capacity of transmission line. So surge impedance loading will help you to do that. Okay, these will be helpful for something like 1 mark bit in your something like your transmission transco exams. Okay, these questions, these type of questions, this type of information is very much required current effect, particularly for current effect, and particularly these things. Very helpful. I think everything is fine. I hope so. Is there any problem? Is there any problem with the online class? Can somebody tell me? Can somebody confirm me that? Is there any problem on the online class side? Is everything okay? No problem. Okay, thank you. Thank you. Okay, so to calculate the maximum loading capacity of the transmission line, surge impedance loading will be very much helpful. What is the surge impedance loading? So it is the natural loading will occur if
the capacitive wear of the transmission line, capacitive wear of the transmission line is equal to inductive wear of the transmission line. Inductive wear of the transmission line. Okay, simply the surge impedance loading Z is given as root L by C. Root L by C. Okay, if a capacitive wear of a transmission line is equal to inductive wear of the transmission line, then the total loading of the transmission line is equal to the natural loading of the transmission line. Okay, that is known as the surge impedance loading. Okay, so usually Z will be 400 ohms. 400 ohms for overhead transmission lines, and Z will be 40 ohms for cables. Okay, because of large capacitance in due to large capacitance, you will get more less impedance, less resistance in the cables, and more surge impedance. The surge impedance loading, more surge impedance loading in the overhead transmission lines. Okay, this is one more point, very important. So, due to the capacitance, again, somebody may ask, what is the reason for low surge impedance loading of the cables? So, it is due to the large capacitance of the cables. That is the reason. So, again, this is one more important point that you can have it in the examination, particularly the transfer exams. Okay, so this is the basic information about the short, medium, long transmission lines. So let us see some problems on this. So again, I'm not discussing about the old problems. I'm only discussing about the new problems. That is from around 2014. Okay, 2014 example. So first question. So in a long transmission line, so my intention is I'll take one question and I'll recap everything. Okay. So something like you read this question, you can answer all the questions from this particular chapter. That is the way that I'm trying to discuss. Okay. In a long transmission line, the R, L, and G and C, R, L, G, and C are resistance, inductance, capacitance, and respectively. Resistance, inductance, shunt conductance, and capacitance per unit length, respectively. The condition for distortion-less transmission, distortion-less transmission line, This is the question being asked in the 2014. In a long transmission line with R, L, G, C are the resistance, inductance, capacitance per unit length, respectively. Inductance, shunt conductance, capacitance per unit length, respectively. The condition for distortion-less transmission is. Okay, this is the question they are asking. So how to go for this question? How to analyze this question? Okay, how to analyze this question? That is the first thing that you have to see. So before that, what this particular chapter is telling you is that any transmission line can be represented in the form of resistance, inductance, and shunt conductance and capacitance. Okay, shunt capacitance. Any transmission line can be represented in this form. So this is R, this is L, this is your G, and your capacitance C. Okay, so mostly we will consider G as negligent in calculating for short, medium, and long transmission line. But basically, a transmission system can be represented in this form. So what is the relationship between these two? Okay, So it is a direct, it's very, very direct answer. So it is given by R by L is equal to G by C. R by L is equal to G by C. Okay, R by L is equal to G by C. So from that, what I can have is RC is equal to GL. RC is equal to GL. Okay. So this is the basic form. So what they are asking is for a distortionless line. Okay. So for a distortionless line, so this is what it will be. So what is that option here in this case is that option is present there. Let me see that. Yeah. So the option is RC is equal to LG, right? That is the option is present. I think it is A. Okay, answer A in this case. Okay, so remember this. So how the elements of a transmission system are being related with each other. Okay, so RL will be the series elements and G and C are the shunt elements. Okay, are the so for lossless meaning completely distortionless is this is what we have. Okay, let us see some more things. Lossless. Okay, if they are saying lossless system, not distortionless, they are not saying as distortionless. Distortionless is this one. Okay, there is no radio interference or something like that. So distortionless is this one. What about lossless? Lossless is, can anyone tell me? Resistance is 0, conductance is also 0. This is lossless. Okay. So please remember that. And surge impedance. Surge impedance. Already I told you that is root L by C. Just I am giving all the formulas because this has been asked. So just I am telling you what are things that we can expect under this. Okay, surge impedance loading is this. The velocity of wave propagation. Velocity of wave propagation. This will be V is equal to Vc particularly velocity of wave, that is 1 by root L. Okay, this is equal to 1 by root. This is another formula that we have to do. So this is simple question. Usually it is not. So let us go with a complicated question, little complicated question. Other than this. So what is that? Because mostly directly formula based questions they have asked in the earlier stages, maybe in the 2000s, 2000 or something like that. Asked some implications. But after that, they changed implications. For a 400 kV transmission line, the impedance is given and the shunt impedance is given. The magnitude of series impedance of the equivalent pi circuit of the transmission line is okay. That mode of condition of 3-phase 58 lossless transmission line has sending in and receiving a voltage of 400 kV respectively.
Sir, voice sir, voice clarity రావాలి sir.
What happened? My voice is gone.
Clarity.
I'm not getting the voice. What happened?
Sir,
Why?
voice is not clear, sir.
Sir, 1 minute. I'm not. What happened, sir?
Voice is not clear, sir.
Voice is not coming properly. Okay, okay. Let me
Yes.
see that once. What happened particularly? Hello, sir. Is it okay now?
Yes, sir. Yes.
Okay, okay. Thank you. I'm looking for a difficult question actually because in substitution type you can easily go for given pi circuit of transmission line is shown in the figure then and x the magnitude of transmission influence on the transmission line is a decision process. Okay, so 2017. Let us go for 2017 question. Uh,
mic was unknown, sir. Off sir. Someone's mic is switched on. Please switch it off. I'm getting noise, disturbance here. Yeah, thank you. So, which question I have to take? A difficult question is always better, always. Uh, okay. So 2017 I will take. 2017 question I will take, and uh, mostly see these questions mostly from this particular chapter will come from the long transmission line. So that is where you have to concentrate more. Okay. So let me take one particular question which actually uh, tell you the things that we can do with long transmission line. Let me say for a better question.
Sir, please share screen, sir.
Yeah, interesting. Change. Yeah, that's it. I'm not ready yet. I'm searching for a better question. That is the reason, like, which can explain everything from this particular chapter. Okay. So from 2017, I will take one question. Okay. So mostly consider that most of the questions are from long transmission. So nominal pi circuit they are given. So pi circuit. Consider that a pi circuit is there in the system. Okay, already I told you what is a pi circuit. Pi circuit is where the capacitance is half and will be placed at one half at the Vs and one half is placed at Vr. Okay, so this is Z, this is Y by 2 and this is Y by 2. Okay, this is Y by 2. Right. So this is what they have mentioned. Impedance. Impedance is given as 100 at an angle 8 degrees ohms, and reactance they are given. Reactance X is equal to 3,300 ohms. Okay, X they have given it here. Okay, this is X. This is X. So figure they have taken it like this. Okay, they are not considered it as Y by 2. They have considered it as X. Okay, X here and Z. Figure they have given here, Z and X. Okay, let me draw that figure. Whatever the figure they have given, this is the figure they have given. This is Z. This is X. This is also X. Pi and pi represented. They are giving it clearly. This is pi. Okay, the magnitude of characteristic impedance of the transmission line is. So they are asking the magnitude of the characteristic impedance of the transmission line. In ohms is, so up to 3 decimals ki immediate. Up to 3 decimals. So it is also a fill in the blank. 3 decimals. If you can remember the formulas, again it is just simply just substitution of the formula itself only. It's not a difficult, a complicated one. So they have given Z value. They are asking. They are asking the impedance of the transmission. Okay, characteristic impedance of the transmission. Okay, can anyone tell me what is that they are asking? Can anyone tell me what is they are asking? They are asking simply what is your surge impedance loading, nothing more than that. Okay, already ZC is equal to root L by C. Already know this formula, but they are not given that in that particular form. You have to determine that, right? How to determine it. So they are asking that into the pi form. Okay, so what is that we have is, so you have Z value. Z value is 100 at 80 degrees ohms, and Y by 2. Y by 2 is we have Y by 2, but they are giving it in the form of X. So what I have to take? That is 1 by y by 2 is equal to x. Okay. So what I get is y. I have to get y value. Y value is 2 by x. So that is 2 by 3300. Okay. So this is y value. So if I can write this L by C in the form of impedance and admittance value, So ZC is equal to root Z by Y, impedance and admittance value. Okay. So something like impedance value will be in series. So L is in series, right? So how you get L? So this is L value. L value will be in series with the transmission line, and the capacitance will be in parallel with transmission line. So this is admittance value. This becomes admittance value, and this becomes your inductance value, or simply Z value. Okay, series element value. So this is Z value and this is Y value. Okay, so I can convert this into Z form. This is Z and this is Y. Okay, impedance and admittance. So that is Z by Y. So here there is 100 by 2 by 3300. Okay, so around 400, 406, I think I converted 406.20 ohms. So I have already told you for overhead transmission line, the ZC will be around 400 ohms, and for cables, the ZC will be 40 ohms. Okay, you can clearly see that this 406.20 in this case. Okay, so this is the formula that I have to use in this case. Okay, direct substitution, which is direct substitution. There is no confusion in this. This is a simple direct substitution. And can I take one more question here? Is it possible? What is the time now? It's 41. Okay. What should question I take? See, I'm taking the questions, and if I'm able to do it with formula, I'm doing that with formula. If at all I'm not able to do that, I'm telling you what is the formula that you have to use it in this case. Okay. So which question I can tell you? So is it okay? Very lengthy questions are there. Mostly, like most of the things you can directly do them. Yeah, one question I can take. I think 224. This has been asked in 2014 only. So luckily in 2014 you got two questions. So two questions are there. Maybe linked questions. These are linked questions. Yes, right. So I think you can get 4 marks out of this. This is very simple question. Again, the same subject loading only. So for a 400 km long transmission line, so I'll conclude with this problem. So this chapter is also like most of the things are complete. The series impedance, the series impedance is 0.0 plus j 0.5 ohm per kilometer. Ohm per kilometer. Series impedance. And the shunt admittance, say same question, there is no change in this, but just they are asking that in the form of complex values. Okay, so please see that it is whether it is asking the complex values or is it in which form. If you can figure it out, it is very easy to do this particular problem. The magnitude of series impedance, series impedance magnitude of series impedance in ohms of the equivalent pi circuit of the transmission line. dash. Okay, so they are simply given the series impedance and shunt admittance, and they are asking for the series impedance of the equivalent pi circuit of the transmission line. Okay, so ట్రాన్స్మిషన్ లైన్ ఇచ్చారు, ట్రాన్స్మిషన్ లైన్ లో ఇంపిడెన్స్ అండ్ షంట్ వాల్యూస్ ఇచ్చారు. ఇచ్చిన తర్వాత వాళ్ళు ఏమడుగుతున్నారు, సిరీస్ ఇంపిడెన్స్ యొక్క పై సర్క్యూట్ లో సిరీస్ ఇంపిడెన్స్ ఎంత ఉంది అనేది అడుగుతున్నారు. ఓకే, దిస్ ఇస్ వాట్ దే ఆర్ ఆస్కింగ్. సో ఇట్ ఈస్ అగైన్ డైరెక్ట్ సబ్స్టిట్యూషన్ only, there is no much things to remember here. Okay, so let me go for one more thing here. Yes, so formula for here is series impedance pi model long transmission line. Long transmission line. Okay, series impedance pi model long transmission line. So that is Z dash, which is given by B, that is ZC sin H gamma L. Okay, so ZC, your surge impedance loading, that is Z by Y. Already these values are given. So the Z value is given as J 0. What is that? J 0.5, and this is J 0.5. Okay, so this is J 0.5 by J 5 into 10 to the power of minus 6 micro. They have given it in micro. Okay, there is a micro. So I have taken 10 to the power of 6. So if you do that, it will be 316.227 ohms. So what they are asking this one, right? We have to find the gamma L value. The gamma formula is root into Zy. Okay, root into Zy. Gamma is root into Zy, root of Zy. Okay, this is Y, series impedance. So this is equal to root of J 0.5 into J 5 into 10 to the power of minus 6. So gamma L will be, this value into L value. Okay, L value. So L value they have given 400 kilometers, right? They have given 400 kilometers. So this value into 400 into 400. So the total will be gamma L will be J 13.23 degrees. Only I am taking degrees. I'm not talking about the magnitude. Okay, so that will be around sorry, for this. So it will be around 0.6324. My calculation, according to my calculation. So 36 degrees I'll take. So Z dash is equal to ZC sin H gamma N. So putting everything into that. So finally my B value will be J 13.689 ohms. Okay, substituting everything into this, we will get this one. Okay, so I think these are the things that you can expect in the system in this particular chapter. So mostly you have to concentrate on long transmission lines. So mostly you have to, sorry for that, yes, come to the top. Mostly you have to concentrate on long transmission lines. Okay, this is your main concentration. So in that, so ZC is one formula, that is L by C, which is also equal to Z by Y. Gamma is one formula, so gamma is equal to Zy or root LC. Okay, wave propagation, wave velocity, that is 1 by root LC. Okay, and the ABCD parameters, cos h gamma L, ZC sin h gamma L, 1 by ZC sin h gamma L, and cos h gamma L. So these are the few things that you have to remember. Uh, okay, so if you have these formulas, summarization of all these formulas, so you can easily solve this problem, any problem from particular chart. Okay, but sometimes in order to find out these L and C values, it may link with your first chapter. Okay, L and C values find out చేయడానికి మీకు ఫస్ట్ చాప్టర్ కి లింక్ చేయొచ్చు. సో L is equal to 2 into 10 to the power of minus 7 ln GMD by GMR. Okay, and C is equal to 2 into 10 to the power of, sorry, pi epsilon naught by ln D by R. Okay, please remember that L and C can be linked to your first chapter. Okay, so L and C can be found out from first chapter and can you keep them here. Otherwise, they may directly give these Y and Z values. Okay, Y and Z values. So these are the observations and these are the formulas that you require to solve questions in this particular chapter. Okay, so most of the questions are from this particular in this particular region only, but there are few more things. Efficiency and regulation. These things also need to be studied at least once. Efficiency and regulation. Okay, so voltage regulation is for voltage regulation. So these formulas also, please remember them. Means mostly it is not asked, maybe it may not be directly asked because it's very simple, very small thing to be asked in the gate examination. But like if you are going for other competitive exams, so definitely you require these things. Okay, so voltage regulation, your full load, this is voltage at receiving at full load, at no load, VR is no load by VR. Okay, is it where around voltage drop difference sending end voltage and receiving end voltage expressed as the percentage of receiving end voltage. Okay, so okay, so this is VR dash, otherwise it is Vs minus VR by VR. Okay, how to get this Vs in terms of VR? So can anyone tell me this? How to get this Vs, I mean VR dash from Vs? Can anyone tell me this? Can anyone tell me what is the value of VR dash? No one? VR dash is no load voltage. No load voltage. Can anyone tell me what is that VR? See, it's very simple. Vs is equal to, we know Vs is equal to VR A plus V IR. No load condition, no load means the current that is receiving at the receiving end is 0. So simply Vs is equal to VR by VR A plus 0. So Vs is equal to VR A. Okay, so I want VR dash. VR dash is no load because this is case of VR dash. So consider that it as VR dash from the beginning itself. So VR dash is no load because IR is 0. It is no load. Consider it as IR is 0. It is no load. Okay. So VR dash will be equal to Vs by A. This is how you form the VR dash. Okay. So if you have this, then you can find the voltage regulation. Okay. If at all the sending end voltage is not given, you can find it out from the sorry, if no load voltage is not given, you can find it out from the sending end voltage by A. Okay, this is another form. Mostly these things are not that much asked in the examination. That is the reason I am telling that in the something like in a very small period of time. Okay, next one is efficiency. Efficiency is, everyone knows this. So power delivered at output power by input power into 100. Okay, so that is something like output power is your PR by PS into 100. Okay, receiving end power by sending end power. Okay, so the sending end power can be PS can be given as the receiving end power plus losses. Receiving end power plus losses. Okay, so this is like small information that you have here. So losses in short transmission line is just I square R losses. R is your line impedance. Okay, for medium transmission line, for pi representation, the losses is, can anyone tell me, IL square, the line current, IL square into RL. Okay, so let me show that in the figure. This is RL plus JL, sorry, JXL, sorry for everything. So R plus JXL, this is Y by 2, this is Y by 2, this is Y by 2, this is Y by 2. So current through this is IL. So IL square into RL. Okay, this resistance RL. IL into RL. Okay. So for T representation, what happened here is, this is Z by 2. You have one more Z by 2 here, and here you have 1. Okay, and current through this is IS, and current through this is IR. So the losses in this case, is resistance is, that is Z by 2, right? So Z by 2. So Z by 2 means here R by 2, sorry, R by 2 into ISS square plus IR square. Okay, the resistance will be, the total resistance will be R by 2, because if it is given R, you have to take it R by 2, or otherwise directly mentioned as the half is R or something like this, something like 20 ohms here, 20 ohms here, then take directly 20 ohms. Okay, R by 2 is 20 ohms. Otherwise, if they take the total impedance is, the total resistance, total resistance is 20 ohms, then take 10 ohms. Okay, R by 2. So 20 by 2, you have to take that factor. So this is for losses that is there for T representation. R by 2 into I square plus R square. Okay, I have shown that in the form of figures also. This is IS current, this is IR current. So multiply with this term and multiply with this term. Okay, both are equal. So that is R by 2 into I square plus R square. So this is how you will have the losses So if we have the receiving end power, so then we can find the efficiency also. Okay, mostly these things are not that much being asked into the your gate examination, but these questions can be asked in your regular transport, particularly transport and distribution companies examination. These can be asked. Okay, so efficiency and regulation of the transmission system. Okay, so if you have losses, so already I told you this is receiving end power by receiving end power plus losses. Okay, this is your efficiency percentage. Okay, this is your formula. Okay, if you have these formulas, yes, definitely you can solve some more problems for particularly your transco and genco, transco and distribution company examinations. Okay, so I hope till now I hope I have given some useful information. I don't know whether it is how far I have covered the content or how far you have grasped the information. I hope it is somewhat clear to this point. Okay, if anything that you want to ask me, please put some questions. I hope I am, whatever that I told you, I have explained with some examples also from old questions. If anything else that you require, anything that you want to ask, please try to put them in the chat box, or maybe you can directly ask me so that I'll try to answer those questions. It's 1 o'clock almost. Anything that you want to ask me, please try to ask me some questions. So mostly in this particular topic, mostly about these things will be asked. But traveling wave, some more questions are there. I mean, separately they are asking some questions from traveling wave and wave propagation. I will see them in the next class, next coming up class. Okay. Any questions? If there is no questions, you can log out. If any questions are there, please try to ask them. Any questions are there? Please put them to me. Sir, old question papers? Yeah, definitely. I will try to see the old question papers from past 2 to 3 years, and I'll share them to you. Okay. So, is everything captured? I don't know how many have attended. So, let me check it once. To stop the presentation also, recording also. So, this is it. So yes, if you have any questions, try to ask them. So everything that I told you till now, so there is a chance that you will get at least 2 mark questions, at least 2 marks out of whatever the things that I've covered till now. Okay, remaining topics also one by one I will cover everything. So almost 96 people have logged in. Okay, but at present only few people are there. Right. So these are the things that we can discuss. Anything else? Anything else that you want to ask me? Please try to raise down.